Analysis and design of structural members in Protastructure and having it pass design successfully. It is not a warranty for a structural engineer to begin to produce detailed standard drawings. We have to carry out an interactive designs in order for us to have an economical sections and as well as reinforcement contents of the sections successfully. This is what we are going to be covering in this video, and so you have to stay tuned, stay connected, okay, as we may progress into these presentations. So in this video we are going to be looking at some vital keys for an economical design of all of the structural elements in structure, analyze and design in Protastructure successfully. So stay tuned, stay connected, stick to this video till the end so you can gather the whole knowledge that this video has that will be helping you on your daily structural analysis and design successfully. This method are the method I use daily to carry out my designs for my clients successfully, and these things are working very much effective, and I will be explaining it in details in this video. So stay connected. Don't forget to like, do not forget to subscribe to this channel, and then stay tuned, okay, for more advanced presentations of this kind successfully. At this point, let us get started. Okay, now if you notice, the green light is at the Storey 7th, okay, the last floors. Okay, so now if you want to carry out an economical design of a structure, you have to start from the Storey 1. If I double click on Storey 1, now you see the green line moves to Storey 1. So in the process of carrying out an economical design, so you have to have paper so you can take down some important points which I will be explaining to you shortly. Okay, so now being at the Storey 1, okay, you will have to navigate to the plan view, but by then you have to start from Storey 1, Storey 2, Storey 3. You can see how the green lines are going up, Storey 4, Storey 5th, 6th, okay, before you now get to the last floor. So if you have up to 16, up to 20 floors, you should have to interact, except you will have some stories which are being replicated. Okay, if some stories are replicated, you can as well, after you must have done, maybe for instance we have Storey 2 or Storey 3 and 4 being the same. All right, this Storey 3 and Storey 4, okay, up to 5 being the same. Okay, you can work on one stories and use the structural elements design, okay, and interactive designed successfully for the 2 stories, okay, above successfully. That is also permitted, but you have to start from Storey 1 as you go up the structure with the interactive design in order for you to have an economical sections, okay, of your columns as well as beam. If you start from the topmost story downward, you may not really get it right. Okay, you may not really get it right because the flow of load, the compositions start from the top story downward. So the column sections, okay, at the lower stories carry much load. Okay, so there is no way you can start it from the top story. All right, so this is how this method works effectively. So to show you how to carry out these things, you have to navigate to Storey 1 first. At Storey 1, you navigate to the plan view of that Storey 1. Okay, now this is this plan view of this Storey 1. You have to pay attention. Okay, at this point you will notice that the column I have here are very, very important columns. All right, likewise the column as well I have are very, very important columns. Okay, other ones are important, but these ones are very important. All right, there is a difference between important and very important. Why I said these columns are very, very much important is because these columns are carrying cantilever slabs and beams successfully. Okay, so you see the whole of this cantilever, you can see here, is being carried by these columns. All right, the same thing applicable to these columns, reinforced concrete columns right here. These ones now carry this cantilever successfully. So you pay close attention to those columns to see how you can interact with this column to have an economical reinforced concrete column sections okay, because this is the column that actually carries the whole floors. Okay, this column carries the whole floors. So as you navigate back to the 3D, you will see what I am actually trying to explain to you right away. Now if you come over to this side, you can see that this is the the story 1 columns. Okay, the story 1 through foundation columns, and then this column carry these beams, okay, that carry the slab, which is this is a cantilever actually being carried at the first floor all the way to the last floor right there. Okay, so you can see the load that is coming up to this particular column. That is why I said these columns are going to be a very, very important column that we should pay close attention to it. Okay, so let us navigate to the plan view right here. I navigate to the plan view, and so we make progress. Now, if you zoom closely, you can see the column sections. You have 300 by 375, okay, which is not actually bad sections, all right? But we may not necessarily go by these sections because the reinforcement selections, okay, the diameters of rebars in these columns may not be that economical, all right? So in as much as they won't be that economical, we will have to interact with it, okay, which is one of the keys that you have to carry out in order for you to have an economical column section design in your structure successfully. All right, so now this column we have here, we will have to just select on it. All right, then right click in this drop down menu, you navigate to where you have section design. All right, click on this section design. Once you click on this section design, you can see what we are having right here. Over here are the column designs, and then we have several options right here, okay, which we normally use. This option used to reset the bars and then carry out interactive design again. Okay, we also have the B2, B3, which are the column sections and the eccentricities as well. Okay, these are the lengths. Okay, and then you can see the concrete cover right here. So all of this can be edited here successfully of that particular column we selected. Here we have a table that shows the ratios, the required area and diameters, okay, of the reinforcement as well as the supply areas successfully. We have the table here that consists of the numbers, which are the bottoms and top, as well as the loadings, and then the area moments, okay, as well. We have the shear forces successfully and the levels of the loading combinations that you see over here, and then you see here we have the U ratio, which is 0.77, all right, which is not bad. Okay, it is far less than 1 to some extent. Okay, but now over here is the sections, okay, and then here is the concrete strength and the steel, okay, as well, that it has been used to design and to select the reinforcement for this section successfully. Now we want to come over to where we have the B2 and B3 options, okay, which are the column section 300 by 375 millimeters. All right, so now if you come to this interactive design and click on interactive design, you will have these column reinforced designs. Okay, you have the combinations, you have the design settings, and then a short column. You see the design moment right here. Okay, now critical load combinations, one, it gives you this particular reinforcement, which is 6y25, okay, at 2945.24 millimeter squares, okay, with an additional 2.62%, okay, being applied successfully to get this 6y25 in this particular column, reinforced concrete column section successfully. You can print the report of this here, okay, but now if you notice this is much, okay, if you compare this to the market price of the reinforcement, you will notice that this is not cost effective at all. All right, so for you to now have an economical design, because this is not economical at all, it's not economical, you have to just close this dialog and then come over to where you have the sections. All right, select on these sections provisions, and then you can key in, for instance, 500, meaning we are having a column section of 300 by 500. Okay, click on the update right here to now have this rectangular in this shape. Okay, after which come over to where you have the rebar, this reset rebar. Select these provisions to have the rebar being reset successfully, just like this, and then click on the interactive design. Now, once you click on the interactive design, come over to the critical loading combinations. Okay, you will now notice that the reinforcement is now changed to Y 6y16. Okay, originally it was 6y25. Now you are having 6y16, having increased the volume of the concrete. All right, it now reduces, increase the strength and reduce the numbers of steel in the concrete successfully. So you are now in a position to choose between this, but at first, I want to show you more things. Click on the OK options. Take note of this section's selection, okay, which is 6y16. All right, at 1206.37 millimeter squares with 0.8% applied. Okay, click on the OK options right here. If you come over to where you have the B3, right, yeah, change it to 450. Okay, let's see what 450 will give us. If you change it to 450, click on the update options. Okay, now click on the reset bars and then interactive designs. So you can now see what you are having 6y20 right there. Okay, so now we are having three various sections. Okay, three various sections. That is why most of the times I use Procon, because Procon will give you these sections just like this to select from. But in Protastructure, you have to interact it. Okay, you have to interact it just the way we are doing it. We have 6y25, we have 6y16, we have 6y20. So you now choose which is economical. Okay, which is economical? Do we go by 2y 6y20? Do we go by 6y25? Or do we go by 6y16? Okay, that is why I said earlier. Okay, so in your daily design, you have to learn how to pay close attention to your structural design in order for you to have a standard design successfully. So in this case, to me, I will go by 6y20. All right, I will go by 6y20 at 300 by 450 column sections. 6y20 at 300 by 450 column section. So let's say, for instance, we reduce these column sections. Okay, let's say, for instance, we reduce these column sections to 300 by 300. Let's see what we'll have right here. Okay, I click on the update. So this is now a square column. So I click on reset bars and then interactive design. So you can see I have 8y25. 8y25. All right. So this is quite very high. All right, this is very high. It will be very expensive, okay, to carry out all these constructions. Okay, so I will advise this. Okay, I will not advise this at all. Okay, we are looking at up to 6 floors. Okay, up to 6 floors. So I may take this back to 450. You will notice that not all the structural columns in this floor will carry this reinforcement selections. Okay, these numbers of reinforcement selection, not all. It is because these columns are cantilever columns, okay, which actually carries the cantilever. Okay, so you pay close attention to it. We go by 450 update and then click on interactive designs. So you have this, which is 6y20. I may go by 6y20. Okay, click on the OK options, and then if you check the U ratio here, you see the 0.81, which is not bad. This column is not going to crack because it is not very close to 1. Okay, it's not that too close to 1. We know we have 9. Okay, before you now get to 1. Okay, so this is a good design successfully. So these are the points you are going to be checking. The U ratio is very important. Okay, so you cannot know if you had more volume of concrete to the column sections. I click on the OK options and then I will click on the OK to have this applied successfully. So you can now see now I'm now having 300 by 450 column sections. Okay, for this particular column, originally it was 300 by 375. Okay, so this brings to your mind that having carried out your analysis and design, and you have all of the columns as you can see from the Storey one, which is ST1 right there, all the column passed, it doesn't guarantee you to actually proceed to produce your structural drawings. But have any question, you can drop it in the comment sections. Okay, or you want to carry out a full training understanding of Protastructure completely, or the type of foundations in Protastructure, or we are carrying out a very essential training. Okay, you can get to us through the link in the description of this video, and we will train you to become a master users of this software successfully, okay, which is what we use in our daily structural analysis and design in line with other software, and then we check it using manual method to make sure that we are very much safe. So we make progress. At this point, let us check this particular columns, this one. Let's check the design. So we select that, right click, and then sections, design. So you see what we have here. What we have here is we are having 3 reinforcement, and then the reinforcement is Y16. Yes, we set that and click on interactive design. You're having 6Y16 right here, okay, 6Y16 right here. So click on the OK. The reason why we are having 6Y16 right here is because of the column locations and the load sharing method, okay. So there is no much load on this column, okay. Now I want to click on cancel right here. I want to show you something. Between this column and this particular one, you can see that this column carries much load right here, okay. This one carries much load because you can see a very wide panel here, 2 wide panel here, which also sent load to this beam, So half of the load on this beam comes to this column, half of the load on this beam comes to this column, half of the load on this beam comes to this column, coming to the cantilever. On half of the load on the cantilever also come to these beams and then to this column. All right, so that is why these columns carry most reinforcement. Okay, now come over to this one we have checked, and then we have 6Y16. okay, now this one, there is no much bigger panels right here. All of these panels are just smaller panels, so the load here coming on this column is not that much. Okay, so this column section can as well be reduced successfully, and you will still have what you actually called an economical design. Okay, so these are the points and the keys that you have to actually have it at the fingertips. So in the process of carrying out your design, you apply them to have a standard design successfully. So let's get back here. I will click on the sections design. So in this section design, okay, I have talked about many of these things. So let's get to the B3 sections, and then we have to change these sections to 225 by 225, 225 by 225, okay, which is 9 inches, okay. 9 inches is just like the width of the blocks, concrete block we used, okay, in this part of the word. Click on the update option, so you have this, okay. You can reset bars in these provisions, okay, to at first have 4 bars, okay, and then you can click on interactive design, which will now have this, and then you can see warning right there. Still bars cannot be selected because of the sections is not sufficient, okay. Section is not sufficient, okay, so we are using a very low section, so you have to now increase it. So in this in doing this, you are carrying out your structural interactive design. Okay, click on the update again. Okay, reset the bars again, and then click on design. So you can see still ratio limit, okay, exceeded. So we click on the OK options. You can see over here U ratio is even increased to 3.64 right here, which is not good at all. So let us go by 300 by this B2, and then B3 will be 300 as well. Okay, click on the update options. Sorry, that is supposed to be 300 updates, and then click on the reset bars and interact. Now you see we have 4Y25 right here, okay, which is not it's not economical. So let's go by that sections of 200, 350 right here. I believe we may have an economical sections here, 350, and then click on design right here. You can see 6Y16, okay, for 350 instead of 375, okay. 350 we have 6Y15 right here. So we can go by this. You will notice the other section we have it to be 300 by 450, okay, which is this particular sections right here. And this one you are not having 300 by 350. So you can see the differences in the design, and this is how design is supposed to be. If I click on the OK, you can now see here we have 300 by 350 millimeters. Here is 300 by 450 millimeters. So all the column sections in the structure must not be the same. So columns are being designed based on the load that is coming on it, all right? But in some designs, you will notice that all the columns, they will make it the same, which is a very wrong design, okay? They will make it the same, so they will say this for the sake of constructions. That is why you are a structural engineers, okay? When you get to site, you pay attention, a close attention to these things to make sure they are all being implemented successfully, okay? So this is how it works effectively in interactive designs to have an economical design of our reinforced concrete column sections. The same thing applicable to beam, but in this video we will dwell deeply on reinforced concrete column economical design. Okay, so we make progress. This is the column sections. You have to take note of these column sections because you are going to be designing the next floor, okay, interacting the next floor based on what you have at this floor. Okay, you cannot just go and have 400 by 450 at the second floor, while at this floor, which is the first floor, you are having 300 by 450. That will not work. All right, that will not work. Okay, the lowest structural floors, the lowest structural floor of a building carries the largest sections of reinforced concrete column. Okay, just like we have it here. Over here we have ST1. Let me minimize all of this. ST1. Okay, so this ST1, which is the Storey one, should carry the largest sections of a reinforced concrete column compared to ST2 and up to ST7 successfully. Okay, if for instance you are having ST1 to be 300 by 300 and ST2 to be 400 by 400, that is an error. It's a very big error, okay, in the course of structural design. It's a very big error, so you have to check your design successfully to be sure what is wrong with that design successfully. That is why I said if you have pen and paper, you take down these things and then ensure that as you make progress into the next floors, you are taking notice of the columns and the sections that you have designed successfully. Okay, so now let's look at this particular one, which is 300 by 7375. Select it, right click, and then we go to section design. So in this section design, we can see this. Just click on the reset bars and then you can interact. Let's see what happens here. It is 6x16 right here. Okay, so this one too can also take 350. All right, can also take 350. Click on the update and then you can click on designs. Okay, so 6y20. All right, 6y20. This give us 6y20 at 350 by 300. 6y20. So you can see that the reinforcement selections in these columns are quite very varies. They are varies. They are not the same. Okay. This other one, the last one, the redesign, we are having a 6y16 actually at this section. At this section, we are having 6y16. Okay. But here we are having 6y20, and then you can see the U ratio is 0.82. Okay, which is not bad. Okay, click on the OK options to apply that successfully. So you see what we have here. This column, and this column. You see the section are the same. That is why I said close attention is the key. Close attention is the key. Even in when you are carrying out your detailed drawings, close attention is always the key. So this column and this column are the same section. Okay, but the reinforcement in it are different. So automatically they are not the same column. All right. They are not the same column because they are not carrying the same load. Okay, why is this one much higher? This one is more higher because you can see a larger panel here. You can see another panel here. You can see panel here. But these ones, the panel around it are smaller panel. Okay, but in this we have another larger panels here. Okay, the column that I think is going to be much smaller is this one. Okay, this one only consists of this beam, and this beam. Okay, which half of the load comes on it successfully. Okay, so now this column, what I'm trying to say is that this column 300 by 350, this one 300 by 350, they are not the same column because this reinforcement in it, in this one, the reinforcement in it is 6y, is 6y20, and this is 6y16. That is what makes them a different column. But in section, they are the same. But in reinforcement design, they are not the same. So you have to pay close attention to it while you are producing your drawing to keep this column separate so that it can be implemented accordingly. Because if you go beyond these sections, you can choose to go beyond these sections. Maybe you may use 400, 400 may give us some selections of 6Y 16 successfully, as the case may be. But in whichever you go, you have to take note of it successfully. All right, so we make progress. Column C, 1C32. Okay, we select it, right click, and then let's do the section design. Okay, and we reset the bars and then interact to see what I have here. So I have 6Y16. Click on the OK options. Now let us try 350 by 300 update. Reset the bars and then interact. We have 6Y16 as well. Okay, nothing changed. 6Y16 as well. So let's try 300 by 300. Okay, 300 by 300. Reset the bars, interact. We are having 4Y16. We are having 4Y16. Okay, click on the OK options. We want to try something right now. 250 by 250. I know that the column doesn't carry much load actually from experience, so but let's just see what this section will give to us. Click on reset the bars and then interact it. We are having 4Y20. Okay, so I believe we can go by these sections. 4Y20 we give us 250 by 250 column sections, which is going to be a little bit small column sections. Okay, because we are also considering space when we also choose column section. It's very, very important. I click on the OK options and then I click on the OK again to have that implemented. You can now see. Okay, so likewise, most of these columns we will take these sections, okay, along these columns here at this cantilever, because they are not actually carrying much load. Okay, so you can check this as well, and then you come to section design. Okay, we can just check this first to see what is the design, okay, which is 6Y16, all right, and then we can choose to just go straight away to 250 right there. Let's see what we have. Okay, update it, and then you can do your reset bars and then interact to see that this doesn't pass design. Okay, because the steel ratio limit is exceeded. Okay, so we click on the OK options, and then you can see the U ratios has even increased even more than 1, which means the column is actually crushing. It's actually crushing. Okay, with that sections. Okay, all right. So what we will also look at too while we are designing is the beam sections. Okay, we have to pay attention to the beam section. Like this column, we have it to be 250 by 250. You notice the column is now smaller than the beam sections. Okay, which is not model enough. Okay, this particular column is not model enough. So for the sake of our beam sections at this floor, we will have to see how we can change the sections to 300 by 250. Okay, so the beam can flush very well. All right, so now let's check this side. We will take this side to 300 and then we update, and then this is what we are having. Let's look at these columns. Okay, this is what we are having. All right, let's click on the updates and then reset bars and then interactive design. We are having 6Y25. This is I. This is I. Let's go by 300 by 300. Okay, and then reset bars, interactive design. We have 4Y25. Okay, that is I. 4Y25. We'll go by 350. Okay, and then interactive design. After reset bars, I have 6Y16. Okay, I click on the OK options, and okay, we can go by this. Okay, so here's the column we are designing, this one. Okay, so this is what this gave us, and then over here we have to increase this. Okay, we will have to increase this. We have to increase this. Let us take this to 300. Okay, click on the update and then the reset bar and then interactive design. So we are having here to be 4Y16. So you see over here we have U ratio to be 0.8. Click on OK options. OK options. So we have these columns just like this. Okay, so we will going by 300 by 300 for the sake of the beams sections at this floor. Okay, so we select this. Okay, and then we will right click and then go straight away to section design. And so we have here to be 300 as well. We update that. We set bars direct for Y16. We go by that. Click on the OK options. Okay, so we have that successfully designed. So the same thing will be applicable to all of these columns. Okay, that has been designed. You have to interact it in order for you to have an economical design. So we want to go to the next floor. Let's see what happened at the next floor with this one that you have designed successfully, which is the Storey 2. All right. So now we have this at 300 by 450. So this is what we are going to be playing around with, okay, at the first floor. But this column doesn't, okay, it seems it appears. This one doesn't appear at the first floor. Also, this one doesn't appear at the first floor because it was transferred to this point of cantilever, okay, which the cantilever's beams now carrying the columns up to the last floor successfully. Okay, so now we select this one and then we right click on this. Let's do the section design right here of this one. So we know that we check all of those columns at the second stories as well as the third stories successfully, because the same method is going to be applicable to every other column section successfully. Okay, all right, here we have here is 300 by 350 right here. Okay, and then we do interactive design. I think this is okay. We have designed this 6x20 is what we're having here. 6x20. Okay, 6x20. We'll go by that. Click on the OK options. With these sections, we are good to go. Click on the OK sections. Okay, we have 350. We have 300 by 450, 300 by 350. Okay, and here is 300 by 350. All right. So let's do one of these columns. Let's design one of these columns. Although at this point, at this next floor, we were having another cantilever that actually takes from these columns upward. All right. So let's see what happens here. Okay, at the second floor. We navigate to the second floor right here. So this is how the second floor looks. You can now see that these columns we have here, they are no longer existing. Rather, we have a beams here, which now receive it from this end. All right, so these ones are 350 by 350. Okay, so we may also check what is the design of the reinforcement. So you can see at 350 by 350 we are actually having about how many reinforcement here? 8 numbers of reinforcement at U ratio 0.8. okay, if I try to interact this now, you see is 8y25. 8y25. So you can see the column sections here. The column sections here is 350 by 350, and the reinforcement, as you can see, is quite very high. And at this point, because it is at cantilever beams, you may not necessarily be able to actually change these sections, as you can flexibly change the sections at the first floor. All right, you may not be able to change the sections. If you want to actually increase the sections, you may increase it along the beam directions. All right, you may increase it along the beam directions. So you have to be calculative while you are changing this type of sections that is being carried by the cantilever beam. Okay, so let's try something to see how we can be able to reduce this steel bar, because Y25 is quite too high. It's quite too high. All right, so let's see how we can do that. We go by let's say 450 right here. Let's see what happened here. Okay, 450. Okay, click on the update and then let's interact here. Reset the bars and interact. Okay, 8y20. Okay, these are reduced to 8y20. Okay, and then let's click on the OK options and see the U ratio. This is 0.86. Click on the OK option. Let's see what happened to that column. So you can now see what happened to these columns. This column has shifted out of the beams line. Okay, so we don't know this ratio, okay, of extensions, but you have to as well work on this column to make sure you bring it in. And then this other side that is 350 will make it 300 successfully. So let's right click on this, and then we will have to click on section design. Okay, this side we have 350, we're supposed to make it 300, and then here let's just make here, and we make here 500. Okay, and then let's click on update first and see what design we actually gives us. This is 6Y25. I wouldn't want to go by Y25, that is just the case. Okay, I would not want to go by Y25. We are making this 500. What will it give? Okay, because it is not good for this column to be too wide. Okay, I reset the bars and interact. 60 giving me 6Y25. You know, this column is actually carrying load. This is the column that is actually carrying load, because as we are changing and working on these sections, okay, we need to go down to the first floor to also work on the sections that is carrying that cantilever beam, which supported this particular column, the first concrete column section successfully. Okay, so I wouldn't want to go by 25, but with these sections I've given here, I think this is the limit I can go at this level. Alright, this is the limit I can go at this level, so that the beam will not be that much deflected. The deflection will not be dipped that much, but I can still reduce these sections. Okay, maybe we'll go by Y25 at this column. Okay, if I do 450 right here, and then I click on interactive designs, having 6Y25. If I do 400 right here, okay, so you have to check, you know, when you are designing a complex structure of this kind, you have to check all of this to make sure that you are safe. Okay, so if we do 350 right here, what do we still have? Do we still have the same 8Y25? Okay, so you can see the same sections at 350. So there is no need we go into a larger sections. We can go by 300 by 350. Let's see 300 by 300, if that will still give us that 8Y. Okay, it still give us 8Y, so you can now see, and everything works effectively. I believe we can go by these sections. This section is as small as possible. So click on the OK options to have it just like this. Okay, this is very modern. This is very modern. So all of these are just 300 as well. All of these are 300. So we go by this section successfully. Okay, at this level. All right. So the same thing applicable to every other columns here. You have to carry out the interactive design to make sure the reinforced concrete column sections is quite very economical. All right. So if we go over to the 3D, we navigate to the 3D. So now all what I've explained, the same thing will be applicable to all of these floors for the reinforced concrete column section design. All right, you make sure you check all of that. You have to spend time and then be very curious about your design, so you can be able to have an economical design before you cannot proceed to carry out the structural details, drawings of your structural members successfully. Okay, so you have to actually do this before you go to the foundations. So you can see we have now designed these foundations, okay, which we may be doing. We'll be doing that subsequently. Okay, we are going to be considering by foundations in this design. Right, so if you have not subscribed, subscribe and stay tuned and see how we can economically design the pile cap, as well as numbers of piles that will be carrying and the structure at each of these columns based on the axial load, okay, generated from the superstructure. Okay, so now we are going to be stopping here. All right, we'll see in the next presentations. Stay tuned, stay connected, and then have a great day ahead. Bye for now.